Good morning and good evening, everyone. So in our last session, we discussed, so we are in Terraform topic now. So we discussed module development. So now you know how to develop a module. So in so this is the Terraform concept. If you know about the service, okay, you can easily refer the documentation and you can develop the module so that others can use in your project or company. So we developed VPC module the last time, and then we created VPC subnets, route, and then route tables, routes, NAT gateway, and a database subnet group, route tables and associations. Everything we have created, that is through the module development. So in Terraform, you have two options. Either you develop your own module or you use open source module. Okay. So based on the project requirements and project size, you can take the decision, but nothing is a right answer. Everything, the right or wrong, is based on the situation and the project business. Okay, so we should know both ways. Right now we are learning how to develop a module. So last time we developed Terraform AWS VPC, and then we used it, we pushed to the GitHub, and then we used it. Okay, so that is, yeah, like this. You have to refer the source like this, and you need to send the variables like this. Okay, now the same thing we will delete this session. Yeah, so this is the one. Okay, so today we will develop one more module, that is security group. Okay, so I'm just going to create one more folder, Terraform AWS security group. Okay, so in RoboShop infra user, I'm going to create one sg.tf. Okay, I will use here. Okay, I'm developing the module in Terraform AWS security group. Okay, main.tf, and then variables.tf, and then outputs.tf. So outputs.tf is very important so that your users should know what is the ID, what are the parameters the resource giving us, okay, so that they can use it later. Okay, so now we can refer the documentation and then create the module. Okay, Terraform AWS security group. Okay. So now our module security group. So users can pass the inputs. Okay, we need to create security group. Okay, so here we have inbound. Generally inbound users can pass the inbound. Now let us take that one of the example. AWS security group can just say something like main. So this one, I want to get it from the user. I'm just giving it as SG name, security group name, and then var.sg underscore description. So they need to provide the description and VPC ID, var.vpc ID. Okay, address you can keep it. In tags, you know, we have our merge function, merge name equal to var.project name and then hyphen var.sg underscore name. Okay. So here users are giving SG name and SG description. So we want to give that, for example, RoboShop hyphen allow all. So then anybody can easily understand. So this security group belongs to RoboShop and it is allowing all the ports. And then var dot common tags and var dot sg underscore tags. So we need these inputs from the users. So egress, we can keep it, but ingress, it should be dynamically come up. So you know that dynamic block, dynamic. So users can provide any number of ingress, so that we have already developed it here, I think, inside for each. Okay. So this is the ingress block. It is going to be repeated, and you need to iterate over through var dot ingress rules, and this content is going to be repeated. So that is what the same thing we are going to do here for each, and then this block should be inside content. Okay. And we will get it ingress dot key or something. What is it? Let me just see this. Ingress dot value of description. How user should provide the variable is like this. Yeah. So they have to provide the list of ingress rules they want. Port number 80, port number 443, and port number 22. Actually, this is a list. This is a list. Inside we have maps. Okay. For the first time we are iterating, we will get this one. Okay. Each dot value dot from port, each dot value dot to port, each dot value dot description, like that. It's nothing but ingress. So you know dynamic block will make this as variable. Okay, the same thing I'm going to keep it. You already know this, that's why I'm moving it. Ingress dot value of description, ingress dot value dot, you can give any format like this. You can give like this, or you can give like this. Okay. Yeah, that's it. Now let us prepare our variables. Variable sg underscore name. I'm making it mandatory. Okay. And variable sg underscore description. I can make it optional. Default equal to, you can keep an empty. And then what else we have? VPC ID. And this is mandatory. Variable VPC ID. Okay. That is mandatory. So I'm not giving any default value. And then ingress. The ingress is not mandatory. Okay. Customers can create. Let me give variable as ingress rules so that we don't confuse, or SG ingress rules. Okay. SG ingress rules. So this can be empty like this. Okay, so without ingress rules also anybody can create the security group. In future, they can add the ingress when they want. Okay. Yeah, this is the definition. And outputs, we need security group ID. What is the ID it created? We need that. Okay. Value equal to module AWS underscore security group dot main dot ID. So as a module developer, we are creating the security group, we are adding the ingress rules, and then we are sending the output, the security group ID that is created. Okay, so these are the variables. So now let us configure here. I'm going to call this module as allow all SG, allow all security group, and the source is Terraform AWS security group. Now, we need to provide SG underscore name. Okay, so that name I can say it is like allow all, and then SG underscore description, allowing all ports from internet. Okay, this is the description since we are allowing everything, and then ingress SG underscore ingress rules. Now I'm giving as a variable. So ideally you can keep them also in variables. Okay. Now SG ingress rules in variables, you need to keep it. Variable SG ingress rules default. Okay. So inside map, it should be from port. So this from port is 0, and then 2 underscore port equal to 0 to allow everything. And then protocol equal to -1 if you want to allow all traffic, and then description allowing all traffic from internet, and then CIDR blocks that is equal to like this. Okay, so let me first, this is the variable. So we have given everything, I think. Okay, let me first create the infrastructure, commenting this. And we need VPC ID also. Okay, first let us apply. So that VPC should be created. Okay. So let it create resources. Now let us start. So we need VPC ID, right? VPC ID equal to local dot VPC ID. So we are capturing the VPC ID and storing it in a local variable, and I am using that inside this. Okay, and what else is mandatory? SG ingress rules, VPC description, name, everything is given. So now what will happen here? So it will call the AWS security group module, and it is sending all the variables it requires: SG name, SG description, and then SG ingress rules. Okay, so this is not mandatory, but still I want this all traffic, allow all security groups. So I'm sending it, and then I'm giving the VPC ID also. Okay, so now, so this is one project. Okay, RoboShop infra user. So you may start another project in future in this entire RoboShop, because RoboShop is a very, very big e-commerce project. So the business will continuously increase. You will start the business in multiple countries. Okay, so another Terraform project may also be started for something else, some different component. So at that time, you need to know this VPC ID, subnets, everything, because for one project in one environment, we will have one VPC generally. Okay. Suppose if any new project comes up within this RoboShop, like any new component like ratings, dispatch, and something else like reviews, everything, many different projects may come up. At that time, they need to provision their resources again inside this VPC. Okay. So at that time, they want that VPC ID, public subnets, security group IDs, everything. So for that purpose, generally, so we have something called parameter store inside AWS. So you can just say parameter store. The parameter store is nothing but where you can store your configuration. Okay. Centralized storage and management of your secrets and configuration data, such as passwords, database strings, something, whatever you want. Okay. Now I want to store VPC ID so that another project can refer that. That is my intention. Okay. So this parameter store is very important generally. Centrally store the configuration so that any other resource in AWS can refer and reuse. Okay. So within this project, within this infra project, you can refer the locals variable within this. Suppose if I start another project for another project like this, like ratings infra. Assume this is the future project, ratings infra. How can I get the VPC ID for this to start to create the resources, like a new EC2 instances? How can I get? So this ratings infra will refer this parameter store and it will fetch the VPC ID. Okay. So it's our responsibility to store the value here. Just click on create parameter. You need to give the name and then value. That's it. This is again key value pair. Okay. What is the key? What is the value? So how you store the key is very important in parameter store because this AWS account can be used by multiple projects like RoboShop, Amazon, Flipkart. So many projects may use the same AWS account. So for that purpose, you need to give something like project name and then slash environment slash what is the ID. For example, VPC underscore ID. Okay. And you can store the value VPC 1, 2, 3, 4, 5, 6. And then create parameter. It should start with slash. Okay, now by seeing this parameter name itself, you can understand this parameter belongs to RoboShop project and it's a dev environment and it is VPC ID. Now, if you open and then you can easily get the value. You can see data type is text and then string. The value is like this. Okay, so it is our responsibility as an infrastructure engineer to store these values in AWS parameter store so that in future projects can refer these values. So we need to store here. So we have AWS parameter Terraform. It is very simple resource. Just you need to give name, type, and then value. Okay. So here I will create another file that is called parameters.tf so that everybody can understand what are the parameters we are storing. Okay. AWS SSM parameter. I want to store VPC underscore ID. So name equal to slash RoboShop slash dev slash VPC ID. Let me delete this. This is the naming convention. It's not mandatory, but it is the best recommendation. Type is string. Value is local.vpc ID. Similarly, I want to store public subnet IDs. Okay, can keep public subnet IDs, local.public subnet IDs. Do we have? Yeah, and then private subnet IDs and database subnet IDs. And we have database here. But this is not string, right? This is the list of IDs. So we can see what is the list here. Any option? String list. Okay. So you have string list option here. Let us give this as string list, and then this one as string list, and this one as string list. Okay, I'm storing here as well, and this is the security group, and I want to store the security group ID also. Generally, you can get it through the locals. You can store it. Allow all security group ID, for example. Equal to module dot allow all sg dot security group ID, because our module is giving this value security group ID. I'm storing it in a local variable so that I can use it again. Or you can directly use like this also whenever you require. But for simplicity purpose, I'm storing here, and you can store them inside the parameters also. RoboShop dev allow all security group ID. Okay. Local dot allow all security group ID. Okay, so this is very important, storing it in parameter store. So that's it. Now let us see what happened to our infrastructure. Infrastructure is created. Now I'm going to do Terraform init so that the latest security group module will be initialized. Some error. So AWS SSM parameter resource name was already declared. Okay, so some duplicate name, copy mistake error. Let us see that. Public private database. Why 2 times? Okay, and Terraform init. Okay, Terraform plan. So again, some error. An input variable with name project name has not been declared. Okay. So what is the error? Can you see? Because in Terraform AWS security group, I'm using this var.project name, but nowhere I declared here. Okay. So it means it's user responsibility to send project name as well. Okay. And here also you need to send project name. Okay. That is the error. So you are using it in the module. You are using it var.project name, but where is the declaration? Where you declared I am going to use it. If you are using it here like this var.sg name, you have to declare it. So I declared here. So when you declare here, user has to pass. That's it. Okay. And then you can see other error, var.common tags, var.sg tags. So when you are developing a module, if you see this kind of error, just go through this. Reference to undeclared input variable. So in Terraform AWS security group main, I am using this var.common tags, var.sg tags, but I haven't declared here. If you are using, you need to declare common tags and then var.sg underscore tags. Okay. Now I declared, since these are not mandatory, I am giving optional. But as a best practice, I am passing the common tags, var dot common tags. Okay, now let us plan again. So incorrect attribute value type tuple with two. It is saying string is required, not a string list. Okay, it's fine. Let us see how it is going to store. So it is saying the value you are sending is not a string list, it is a string. Let us see. Parameters. So how is it going to store? We can check now. In the same error, local.public subnet IDs is tuple with two elements, inappropriate value, string required. Let me search this. So simple typing, data type error. Terraform. String required. So we are giving string. And what is the error? Saying tuple. Tuple to string list. Tuple to string list Terraform. Okay, so let me give something like this braces and then Now this should be list. Just for this parameter store, the data types are changed. Instead of list there, they created something called string list. So type conversions are always headache. How to store a list of public subnet IDs in parameter store. Terraform. They are saying we can use like this dot star dot ID. Okay. So inside parameters, what is it? This one. Dot star dot ID. Okay. From the module, this is already a list. Okay, like this. Let us keep this aside. Okay. So this is too much confusing. I'll tell you at the end of the session. So for now, I'm storing the security group ID and I'm storing the VPC ID. I'm creating the security group. Terraform plan. Another option is like this join function. Okay, let us see that anyhow. This is the worst thing in this parameter store. So they created something called their own data type string list. So we need to convert according to them. Let me try as a last option. This one. Just let us change here. And have local dot public subnet IDs. And then this is string list. Okay. Let us check. Okay, this worked. So let me keep it. Let's go for apply. So you can see it is creating security group and then the AWS parameters. And this is done. Now let us check here. So now you can see we are storing all our parameters so that any person can use them. So this is the one it is expecting. Just commas without any braces. Generally list have some braces, I mean brackets, but here the string list is expecting without any brackets. And that's fine. So this is our security group ID. You can also use this whenever you want. And then, yeah, so we got our security group also. RoboShop allow all. And then we have our tags properly given. Okay, so this is the module development. So if you know about the service, it can be either AWS or it can be either AWS, it can be either uh, Google Cloud or Azure or anything. So you should, if you know the service, you can develop the module using these principles. Okay. So now let us understand open source module. So this is very simple. If you know the module development, someone like you already developed the modules and then they kept it in internet. You don't need to write the module again. You can just use it. Okay. So for example, now I'm going to create EC2 instances, but I don't want to write the module from the scratch. I just want to use the available modules in the internet. Okay. So now if you type Terraform AWS EC2 module, okay, you will get it from the Terraform documentation directly. Just go to this GitHub. Okay, here they will give you how to use this module. Just like we have push to the GitHub and then creating the documentation. So they are also doing the same thing. They are creating one README file, proper README file, and they are telling users how to use this module in a nice way. So you have to do that in your company when you are creating your own modules. Okay, and you can see that just like we created main.tf, outputs.tf variables, and then versions just for the information, readme.md. And then they are giving you some examples also. How can you use this module? Okay, complete example. You can just refer this. So this is how you are using the module. Okay, so like how you call the module and then how you provide the parameters, everything like this. Okay, so the same way, I'm going to use this module EC2 instance, this one. Okay, and first we need to provide AMI. You can see this AMI. If you don't provide, they will take the default AMI, I think. Okay. ID for ID of AMI to use for this instance. Okay. Required no. If you don't give, they will take AWS Linux to AMI by default. So we know we are using our customized EMI DevOps hyphen practice. So we need to get it through the data source. So AMI is here, and then this is our AMI. We need to use Terraform AMI data source. Okay, so this is the data source. So let me copy this. So you know very well about the data source. I'm just giving data.tf. I'm keeping it here, and I'm giving DevOps AMI. This is not mandatory. Most recent is true. What is the name? You can just get it from here. Okay, who is the owner? Is this account ID? So you need to provide this. And then the name, again, you can give the same thing. And then root device EBS and virtualization HVM. So you can see root device EBS and then virtualization is HVM. Okay. So now this will give AMI ID for us. So in EC2, you have to give data.aws AMI.DevOps AMI.ID. Okay. So let us just try and then print this. Okay. Let me comment. So in outputs.tf, AMI underscore ID value equal to this one. Let us print and then see. We will get the AMI ID and then, so what else? Instance type. Generally, instance type can take t2.micro. That is mandatory, right? Generally, instance type is mandatory. Key name we are not using. Monitoring is not required. And this is very important. VPC security group IDs. Okay. VPC security group IDs. So now you know local, it's a list actually. Local dot, we are storing it, allow all security group ID, and then what else? Subnet. Okay, I want to keep this in 1A public. Subnet ID equal to local dot public subnet IDs of 0. This means public subnet in 1A region, 1A agent. Okay. And then what else? Tags. Let us see your AMI is printed. Okay. AFP. AFP. Okay. AFP. So in future, if we provide any updates to this AMI, again, you can dynamically get it. So every update AMI ID will be changed. But using this data source, you are getting the AMI ID dynamically. So now this should create the EC2 instance. Now you can see how simple it is to refer the open source modules and then create the resources. So always full documentation is available here, which is mandatory, which is not mandatory, what are the inputs, what is the type, and what is the output it is giving. You can see what is the output. So they have written the outputs just like us. Okay, so this is the outputs from the module developers. Okay. So Terraform init. Terraform plan. So we need multiple instances, right? So you see this, we need only web instance in public subnet, remaining all instances in private and then database subnet. Okay. So we have to deal with this. So one resource to add, it is not a problem, it is working. But right now I want to create multiple instances. So let me give variable, and then I want to give something like instances, and then this default equal to MongoDB. So that is t3 dot medium, and then MySQL, that is t3 dot medium, and then we have Redis, that is t2 dot micro. Redis and RabbitMQ, catalog, user, cart, shipping, payment, web. Okay, RabbitMQ, and then this is catalog, user, and then cart, and then shipping, payment, and web. Okay, so this is how we created earlier also, right? So the same way, but here I'm just giving the loop. Okay, usually for loop we can give it at the start. For each var dot instances, okay, AMI is same, instance type is, okay, each dot value. Okay, we created this already. You can just see in our Terraform. The same way. Okay, and then each dot value, security group is good, and then subnet ID. So here subnet ID, we need to write a condition. Each dot key if equals to web. Okay, so we need to keep it inside local dot public subnet. Local dot public subnet IDs. Okay, let me copy this. Local dot public subnet IDs of 0. Otherwise, if it is not web, I want to keep it inside private. Local dot private subnet IDs of 0. This is private. Okay. So for now, what I can do is I will create web in public and private database, everything in a applications and databases, everything in a private subnet. You can still have a condition to keep if it is related to the database, you can have a still condition. You can keep it inside the database subnet. But for now, for simplicity, if it is web, I'm keeping it in public subnet so that it will get public IP address. If it is not web, I'm keeping it in private subnet. It will not get public IP address this time. It will only get private IP. Okay, so that is the condition there. And then I can always give tags. So what is the module definition here for tags? So you have, that is nothing but tags, you can provide the tags. So what I do here is I will just merge here itself and then name equal to each dot key, and then I will pass the var dot common tags. Okay, so this is how I can create all our instances. Okay, if it is only one condition, if it is web, I'm keeping it in public subnet. Other than web, I'm keeping all the instances in private subnet. So now let us go for plan. It is saying 10 instances will be added. Yeah, let us apply. And resources to add. So all instances are getting created. Let us see here. Redis, you can see private IP address only we got, we didn't get public IP. So that's what the private subnet. So now we need to create the Route 53 records. Okay. Route 53.tf. So again, I want to use the open source modules. You can always search Terraform AWS Route 53 records. This resource definition, I want the module. You can see Terraform AWS modules, Route 53 AWS. So here they will give one example of how can you create the records. So this is hosted zone. Okay, we don't want to create hosted zone through Terraform because it is a manual thing. We need to update the namespace records in our hosting provider. So I want to only use this one, records. So here the options, they are saying, what is your zone name? So this is mandatory, obviously. Otherwise, Terraform cannot create the records. Zone name is like, you can keep this in variable var dot zone name, variable zone name default equal to join DevOps dot online. Okay, so this is my zone name, and then it is saying records. You need to provide the list of records you want to create. Okay, so records, this is a list. Okay, list like this, and then inside can have multiple records. Okay, so name, and what else is important? Type. This one, name, type, TTL, and records. So this I want to iterate. So if you remember last time we did this, that is in for each while creating EC2 instance. So we iterated through the for each. So you are getting the 10 instances here. I'm iterating through that. This is a map. And then here we are getting the IP address. Okay. So now the same way. So what I can do here is in locals, let me give a variable IPs module dot EC2 instance. So now if I type this, I'll get the full information in a map. Okay. So let me comment this and then show you. So I'll get full information of the instances it created in a map. So we got all the instances created. Only web, you will get the public IP address. Remaining all instances, you will not get the public IP address. So that at least your application is secure. Your databases, your applications are secure. Oh shit, not printing it down. Local.ips. Last time we worked on this already. So here you can just refer while creating the records, you can just refer key and then each dot value dot public IP, not private IP. So the same way here, I will write so inside records, I will store this as first I need to for each equal to local dot IPs each dot, this is key actually, each dot key. It's not highlighting, you can just keep like this. Each dot key, a record, TTL is 1, and then here you need to give all your condition. If each dot key equal to web, then the IP address is each dot value dot public IP. Otherwise, each dot value dot private IP. So this will be iterated for 10 times. Okay. And if it is web, it will only take public IP, otherwise private IP. You can see this is the information, complete information. This is the key and this is the value. Inside this value, we have all the information, either public IP or private IP. Okay, so that's it. Now I will comment this. Unnecessary information you should not print. Now Terraform plan. You need to create 10 resources. So you can have tags. Do we have tags option? Okay, I think only hosted zone we have tags. This is our hosted zone. And right now I have only 2 records. Just don't have any tags option. Terraform init. Terraform plan. Okay. It is saying is saying 10 resources to add, and it is removing the outputs. So now this should create the records. So now what I do here is I'll create Ansible instance, okay, through Terraform, and I will write user data. So what is user data? So we have seen this already. So whenever you are creating instance, okay, on successful start of the instance, we want to do few things that you can provide through shell script. Okay, so generally when you create Ansible instance, what you do, install Ansible, right? And then connect to our RoboShop instances and run the playbooks. Okay, so this is what we do. We have all the roles available. What is this? Ansible RoboShop roles. Okay, so we have everything is created here. If I create EC2 instance for Ansible, install Ansible, and if I run this RoboShop project from it, it can automatically install the application. Okay, so let us see that. Let these records are created. You can just check. Now you can see for web it is public IP, and for others it is private IP. Okay, user.joindevops.online. Everything is done. So now I want to create another instance. Okay. Just taking one more module. So this is, I will call it as EC2 Ansible. This is not a loop. Instance type, you can make it t2.micro. Okay, I want to keep it in public subnet so that we can connect to it. Okay, and this is name is Ansible. Okay, so this is t2.micro allowing all public subnet Ansible. Okay, let me do Terraform in it so that it needs to initialize again. So we have a user data option here. Generally in EC2 instance, we have user data. So this user data can be shell script. So what I do here is I'm just giving RoboShop Ansible.sh. Here, you know the shell script /bin/bash. First, I will install. By default, it will get sudo access Ansible-y, and then let me touch something for testing purpose. Okay, test script.sh. Okay, I just created a simple shell script. I want this script to run at the starting of Ansible. So here the option we have user data, that is file module. So inside file RoboShop hyphen is this hyphen Ansible.sh. Okay. So now what this module will do, it will create the Ansible instance. After starting it successfully, it will run this shell script internally, okay, within that instance. So it will automatically install Ansible. I don't need to install again, and then it can create one file for the testing purpose. I'm just doing for the testing purpose. Okay, now Terraform apply. Let me take another window. It is creating one instance. For public IP, but still cannot connect until it is initialized. Now connecting DevOps 3 to 1. Okay, so now let us see Ansible is already installed or not. It's not found, but it may be still running. You can see that log var log, and here you can see cloud init output dot log tail hyphen f cloud init output dot log. So it is installing Ansible in the background. So this is the initialization script. This is, we call it as initialization script. Whenever you create the EC2 instance, at the time of initializing, it is running this. It is automatically installing in the background. So it completed Ansible installation. It is done. Sorry, it's done already. You can just go and check in temp directory. There will be a file created, test script. So it means our user data is working properly. Okay. So now we have to create other thing. What can we say? I'm removing this. I want to clone this. I want to clone our Ansible RoboShop roles. This one I want to clone. Okay. I want to go inside. So first let me go to temp directory. I'm cloning it here. And then here I want to go inside. And then the command here is Ansible playbook -i inventory, and then -e Ansible underscore user equal to CentOS -e Ansible underscore user equal to DevOps 321, and then main.ml. So this is the one we have, right? Generally, what is main.ml here? So you need to pass the component also. Okay, so that is just like -e component equal to, for example, MongoDB. Okay, so it will refer this repository MongoDB, mongodb.join-devops.online. So then it will run it. Okay. So now like this, you need to have MongoDB, and then what is again Redis, and then you need to have this other component, MySQL. Okay. So like this, we can write the commands to configure one by one. But instead of that, I can directly have. Okay, so what can I do here is in main.ml, I'm commenting this. Okay, we can keep like this only. This is fine, just for automation purpose, not for the real. and then rabbit MQ. Maybe you can write a simple for loop here in shell script. Okay. And then here, what is the component? Catalog. And then user and cart and shipping and payment and web. Okay. So now what will happen? It will install Ansible. It will clone the repository. It will go inside the repository. It will configure one by one all the instances. And we have already inventory file inside that. Then that's it. Their project will be configured. Oh, this is password. Okay, thank you. Ansible underscore password. Fine. Yeah, so that's it. Now what I do is, so this is only one time generally. User data will not be updated automatically. For now, I'm terminating this Ansible. Just changing the user data will not have any effect. And just apply it now. This is automatically disconnected. So this will give us new instance. Okay. This is the new instance. Let it come to running stage. So as a simple improvement, you can just write this in a for loop. Okay. Created. Let us try connecting. Configure. Okay, now we can refer that cloud output log tail -f var log cloud out. Okay, it is installing Ansible now. Okay, Ansible installation is done. Now you can see our project is cloned and it is connecting to MongoDB. MongoDB installation is going on. So we can verify the MongoDB. How can you verify? Because you don't have any public IP. So you cannot connect with private IP from your laptop. Okay, so for that purpose, generally, so you can use one of the public instance as a jump host. So in this entire infrastructure, so we have only one public instance like web instance. So from you have to connect to this, and from here you can connect to the any private instance. You cannot directly connect to the private instance. Okay. So what I can do is I can take one public instance web. Let me go to Super 40. This is concept is called as jump host. Okay, when you don't have direct access to the private instance, you can connect one of the public instance in the network, and from there you can jump to the private instance. Okay. So now I'm in web instance. Now I'm connecting to mongodb.joindevops.online. Okay, now I'm inside MongoDB. So you can check netstat-lntp. Now you can see MongoDB is already installed and running on this port number. Okay. So it will be happening for next, it will take at least 10 components, 10, 2 minutes, 20 minutes, right? So you don't need to do anything. You can just give Terraform apply auto approve. So what it is doing, it is creating VPC, it is creating security group, it is creating EC2 instance, it is creating records, and it is configuring the instances as well with a single command. So whenever you want to just see the RoboShop online, so you can just run this command. Okay. So now till now what we have learned. So we learned Linux admin. We learned how to do manual configuration, and we used shell automation, and then later we used Ansible automation, and now we used Terraform to create infra automation, and then Ansible to create configuration. Okay, so we have seen this. Terraform is not at over because so these things, whatever we are using this, MongoDB, Redis, MySQL. We are not going to use VMs. Okay, we are going to use AWS services. We have popular AWS services like RDS, DynamoDB, and then Redis, and then some queue application we have inside AWS. We're not going to use VM based services. We will provision AWS services for this, and then we will configure to the application. Okay, so till now, at least we learned many automations like shell scripting automation, Ansible automation, Terraform automation. So now we have our application with one single click. We can provision the entire application. Now it is time for to monitoring. So monitoring is very, very important concept. Okay. So it doesn't matter how much work you do in the background. So it always reflect in the monitoring part. If your application is running, we don't know how the application will go down, how the application resources will go down. So it is very important to monitor your application. Otherwise, whatever the work you have done in the automation will not be useful. Okay, so you have to continuously monitor your application. It should not go down. Suddenly, if the traffic is very high to your application, also you should get some alert. Okay, suddenly the traffic is very much increased, and then if your application is responding very slowly, still you should get an alert. Okay, because your business will be lost if the application is very slow. If Amazon is very slow, then definitely customers will move to Flipkart and then they place the products there. So your application should be fast responding. Okay, and then handle more traffic, and you should always check for the errors. So you can see we have a lot of 500 errors. Okay, you should monitor for this. If you are getting 500 errors, it means something is wrong. So you know that already. We have seen a lot of 500 errors in the configuration. So you need to handle that one as well. Fast responding, and then handle more traffic, check for errors, and then you need to just calculate how many users our application can serve. So right now we are using T2.micro. If suddenly 1 crore users coming up to the 1 crore users or 1 lakh users started accessing our application, so then definitely T2.micro is not enough. So it's always our responsibility to do the benchmarking. How many users it can serve based on this instance type, based on the resources you have. So this all comes under monitoring. So this is also very important part for the DevOps engineer. So from tomorrow, we can see how can we monitor our application through the ELK and Prometheus Grafana. Okay, if you are interested, you can just go ahead and then start reading about ELK. From tomorrow, we will discuss that. Serial catalog is going on. Yes, we can have few questions now. Any questions? No questions? It's Mahendra.
Hi, like you connected from public IP to some other IPs, right? Like another instance, right?
Correct.
So, what is the need of the you so told about the router and other stuff? If there is a direct way to connect from the public IP,
Mm. So these are the private IP, private instances. Okay. So this
yeah,
is, so you're working on any current technology.
yeah, I'm a Java and AWS guy.
Okay. Generally in our companies, for example, we have our AWS infra, and as said here, we have our public subnet, and this is our private subnet, right?
Yeah,
This is public subnet, an example. So we have one EC2 instance here, and then we have another EC2 instance here. So this is my laptop. This is complete different. Okay, so right now the resources are in America, North America, right? So I'm connecting from my laptop to North America. So if I have public IP address, directly I can connect. So this is private IP. Private IP we cannot connect. Suppose your laptop in your home, I cannot connect to it. Okay.
Yeah.
So generally, what is the way I can connect? I will connect to this public instance. Then I will be inside this instance. From here, there is a connection, right?
I,
So within your home, if you have two laptops, you can connect from laptop 2 from laptop 1. So
yeah.
usually in our offices, what we have generally, we have VPN. So this VPN service is in AWS. Okay.
Yeah, I got this point. My point is, I got what you said. So we discussed yesterday or last week the routing tables and all the other stuffs. So that's my question. What
Okay.
we can connect, we connect this way. That I understand. You're explaining the same thing, but my point is, we have routing tables and other stuff. So when we need to use that
So
routing tables,
from
when we need to
here
use
to
that.
here, from here to here, again, there should be a connection. If you go and just see this routing tables, so every subnet will have the local route.
Okay, indirectly that is connecting.
Wait, I'll show you. Suppose let me take the private right now. I configured in private, right? So here routing table, what is it allowing? So it is allowing the VPC CIDR. If you remove this, then you are not able to connect.
Okay.
So
Okay,
this is the
indirectly.
local. This is the
Yeah.
local. So the route inside this between these subnets is local. If you
Okay.
don't have, you don't even connect. You cannot even connect.
Okay.
Okay.
Yeah, got it. Got it. That's what I want to know. That's indirectly is referencing that. Yeah. Thank you.
Abhishek? Abhishek?
Hello. Hi,
Yeah,
Shiva.
hi. Hello.
Uh, Shiva, actually, I have one doubt. We created for multiple AZ, we created two zones, right? Two subnets.
Yeah, correct.
But while creating, we created EC2s in only one subnet.
Yes.
Uh,
You can create in two subnets, and then you need to place load balancer in front of it. Okay, so we will do that in our upcoming sessions.
but internally, how they will communicate, Shiva? Because internally, we are using DNS name, right? Web.dns.
Private IP address will be used for communication. Even you give DNS, so this is obviously going to give the private IP address, right?
Yes, this one will be for one availability zone, right?
No, here it is the CIDR is for the region. So just now I have shown you. So this is the route. So this route, this is the CIDR, correct? VPC
Yes.
CIDR. This is the VPC CIDR. So your instances can be in 1A, 1B, 1C, 1D, wherever it is. The IP address is going to be in this range, right?
Yes.
So
Right.
in this range, within the region, your instances can connect irrespective of their availability zone.
Okay. Means one subnet host can connect to another subnet host.
Yes, if you have the route available.
Okay.
Okay, we
But
will.
Shiva, actually, my doubt
Mm,
is already we have two. Let's say we have two web servers. We'll
mhm.
balance the load using load balancer. Means we'll deviate the traffic to one zone and two zone.
Yeah,
But
correct.
internally, web server, what we are doing is, if for example, if we say web server to connect to Redis, we are using that DNS name, redis dot joindevops.com.
Yeah, correct.
But that will have only one IP, right? One subnet IP.
Yes.
Sorry, one zone IP.
Yeah.
But same server will be creating in one more zone, right?
Yeah. So at that time, you will keep an load balancer instead of IP address here. You need to give load balancer IP address. I mean, you need to give load balancer name.
For each server, we'll be creating one load balancer.
No, load balancer concept is, we will get that concept anyhow. So
Okay.
these are the two servers. Okay, in between we have application load balancer. So this is the application load balancer. Okay, so this load balancer is connected here and this load balancer connected here. And then in Route 53, okay, so this is the Route 53. So this Route 53 will be connecting to load balancer. Okay. So this Route 53 will connect to load balancer directly, and this load balancer, it will either connect to this one or this one based on the round robin algorithm. If you are sending 30 requests, first request will go here, second request will go here, third request will go here, fourth request will go here.
Okay. Oh, this is for web server, na Shiva?
Any server, either web
How
server
they
or
will
database
connect
server.
to MongoDB?
So then here there will be another load balancer, and here you will have two MongoDB databases, and this one will connect to load balancer, or this one will connect to this load balancer.
Okay.
Okay.
Yes. Got it. Thank you, Shiva.
Most welcome. Santosh Avula.
Hi Shiva, good morning.
Yeah, hi.
Yeah, Shiva, last time you have to mention like Ansible only for the configuration purpose, right? So,
Yeah.
but today you have to mention Ansible also, you give the infrastructure module creation.
No, Ansible to create configuration only, I said.
But only calling purpose only using the Ansible, right? Infrastructure configuration creation, right?
See, infra is created through Terraform. What I used to create EC2 instance, to create Route 53 records, everything I use Terraform only, right?
But
But-
here, yeah, please
But
go ahead.
here inside, I created Ansible server itself through Terraform. Okay. So I created Ansible server itself through Terraform, but inside that I'm running one shell script. So this is Ansible is connecting to the servers and then doing the same thing. Whatever we did earlier, I'm doing the same thing. But here I'm not using any Terraform, right? This is the configuration, pure configuration through Ansible. I'm not doing anything new. I just created one server for Ansible, and then within that server, I'm running this shell script to connect to all our instances and run the playbooks. That's what it is doing here.
So instance creation, you are using Terraform.
Yes, correct.
Okay, but in that instance, you have to call all the methods, like what are the things we have previously done. These things are calling from through this instance.
Yes.
Yeah, I got it. Thank you.
Janardhan?
Yeah, hi Shiva, good morning.
Yeah, hi.
Just checking, like, see, this Ansible rules, we are, you have written the shell script, right? In that we have inventory file. That inventory file is created dynamically, or is it already?
No, we had already earlier. So we are using Route 53. We are using Route 53, right? So even you change the IP addresses, but still that is mapped to the DNS.
Domain names, yeah. That's why from there it's capturing.
Okay, yeah.
Achha. Okay, Shiva, that's it. That's what. And Shiva, one more question. I think just now you have explained to one person, right? Like this, we are using load balancer. Could you please go to that diagram, that drawing?
Yes.
Yeah, here, to connect to the web application, you're using the one load balancer. From again at the back end, one more load balancer you're using to connect to the databases, right? So generally, databases, do we use load balancer? Because
no, actually, just for understanding purpose, right now I use this. Generally, we have high available master databases and replicas. We can use AWS will give us one endpoint. So we will use that endpoint, then AWS will take care of how to route the requests.
Request to the masters and slaves, right?
Yeah, correct.
Yeah, fine, Shiva. That's it. Thank you.
So this is done. We can access our web.joindevops.online now. Okay, so you can place the order. Yeah, that's done, right? So now we can just destroy this. So if you apply, you will get the entire RoboShop up and running. If you destroy, everything will be destroyed. Yes, so tomorrow we will monitor this application. Okay, so if you are interested, you can start reading about ELK.
Shiva, one more question, Shiva. This one, sorry.
Yeah, tell me.
No, I forgot the question. I thought.
So it's okay. So from next session, we'll start with monitoring. So for that, we need to have our application up and running. So you just run this command so that your application will be ready. Then we can work on our monitoring part.
Yeah, Shiva, I got that. See, for example, we are using the user data, right? For while provisioning the infrastructure, post provisioning the infrastructure, we wanted to run some scripts. That's where we are using the user data. Now, assume that we made some changes as part of the infrastructure. So when we rerun that Terraform script, the user data will rerun or it will not rerun?
I think it's not considered. We have another thing that is called provisioning. So usually in real time, we don't use this. Just for the automation purpose right now, I'm telling you. Okay. But this is not the way. So for now, this is okay for us to handle our automations. But I will tell you the right way in our upcoming sessions.
Okay, generally this user data and provisioners, this and all will not use mostly.
Yeah, provisioners earlier we were using in Terraform, but nowadays it is also Terraform is not even recommending to use provisioners.
Okay.
Okay, so you can see that from the documentation itself. So they mentioned provisioners is not that much useful.
Yeah,
Okay,
should
so
be the last resort.
Yeah, but still this is important for the interview purpose. We will discuss that.
Okay.
Yeah.
Thank you. Thank you.
Welcome. So that's all for today. Have a nice day. See you in tomorrow's session. We will start new topic monitoring. Bye-bye. See you.